We can use the command line to diagnose and learn more of our SD-WAN member interface. Coming up. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. We can use our command line while configuring SD-WAN for different tasks. One of them is to use different protocols that will be used towards the server that was chosen in the health check. So if we look at the performance SLA, let's choose one. And we can see that on the graphical user interface, we only have two options to ping our server, that is using ping and HTTP. Now, if we will use the command line, config sys virtual WAN link, config health check. Now let's edit the performance SLA that we have chosen, that is SIP. Let's see what is chosen. Show full configuration, and we can see that the protocol that was chosen is ping. Let's set protocol, and now you can see that we have the ping option, the TCP echo option, the UDP echo option, HTTP, and TWAMP. So that is something that is available on the command line and not on the GUI interface. Another thing that we can do or actually see using our command line, let's use the diag sys virtual WAN link. Let's choose the SIP. You can't see it that way. Let's choose the SIP health check. Now we can see the status of each member in our SD-WAN, in our virtual SD-WAN interface. In terms of packet loss, we can also see it on the graphical user interface, but that is also one way to look at the different members. We can see that it is alive. We can see that we have no issues currently with packet loss, and we can see the statistics for latency and jitter. Currently, the other members are not alive since I have not enabled them on my Fortigate. Now, whenever we use performance SLA, we are actually telling our Fortigate to probe different services. We can configure up to 2 servers that will be used as beacons. We are doing that to check the status, the health of the different members of the SD-WAN interface. Now, whenever our Fortigate probes that server, it is actually using a route entry that is created. Let's see that route entry. So we will use the get router info kernel, and those entries are actually flagged. They are created in the kernel. They are called fib entries, and they are flagged as proto 17. So to see them, we will use the grep command, and we will use the proto equals 17, and we can see, let's make that a bit bigger. We can see the different routes. They are being sent from the different interface gateway towards the different servers that we have chosen. The first one was actually the Google DNS server, which is 8888, and the second one is 1111. Hey everyone, so here we are at part 4 of certificate operations in your Fortigate. This video series spreads some light on the importance of certificates and why do we use them. It is not a tutorial of how to create a self-signed certificate. We will get to that. It is actually the theory behind digital certificates. So what did we have? We had symmetric encryption where the two parties share the same secret key. We also learned of asymmetric encryptions where we use a key pair, a public and a private key, different keys yet related mathematically. And then we had at part 3 we had hash functions, a one-way function that takes any input and transform it into a digest, a hash value that is not reversible and is collision free. That is, no two different inputs can produce the same hash value. Alright, so let's connect the dots. A CA, which is a certificate authority, issues digital certificate. This digital certificate also contain the public key of the entity who requested the digital certificate. It can be just about any web server out there. Another thing that it does is signing the digital certificate. How it does so? It hashes the digital certificate along with the public key and then encrypts it using its private key, using the CA's private key. Now, when a browser connects to a secure web server, it gets the certificate along with a digital signature. Think about it as two different files. It opens the digital signature using the public key of the CA. It has the public key of the CA in its certificate root directory. Now, any browser keeps its certificates, its CA certificates, in a different place. Now, as the file is being decrypted, he gets the hash of the digital certificate value. He then takes the digital certificate, the original one, hashes it using the same hash algorithm that was used by the CA. The type of the algorithm is also present on the certificate itself. We can see it right here. If both hash values are the same, then we have a proof that the entity who sent the certificate is the one who it claims to be. So we have used asymmetric encryption and hash functions to prove the authenticity of the entity. Now, the two parties, the browser and the web server, will negotiate the symmetric encryption that will be used as the encryption algorithm, the cipher itself, to encrypt the communication between them. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the topmost CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the DAG systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now, there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, the new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. Whenever you open an app in your Fortigate, you're actually creating a process. A process is responsible to ask the kernel for resources, CPU resources, RAM resources. How do you manage them? Using the diag sys top command. Let's take a look. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. There are some different ways to sort up the processes that are running on your Fortigate, but one of the most popular diagnose command is the diag sys top command. Now, whenever you launch the diag sys command, you will see the different processes that are currently running on your Fortigate. Now, you can filter those processes using the diag sys top, and now you can set up a number, an integer that will actually behave as the interval between the processes and the amount of processes that you wish to see. I've chosen 5 and 20 processes. So I have 20 processes and the interval that they will refresh is 5 seconds. Now let's take a look at the information that is being shown here. Let me stop just to look at those processes without interfering. So what I have here is the name of the process. New CLI is the JavaScript command line, HTTPS, DNS proxy, and so on. I also have the process ID, which I may use if I wish to kill that process. I have the state of the process, which can be a process that is running, as this one, or a process that is asleep. Moving on to the 2 more pieces of information that we have. The first one is the amount of CPU that the process is using. And the second one is the amount of memory that the process is using. Now you will also see above the processes some gibberish, such as the 99i. What does it mean? It actually means that currently the CPU is currently 99 idle. So there aren't many processes that consume the CPU resource. You can also see the amount of free memory that our Fortigate has. That is the number that comes with the F character on the right. And lastly, the 1S actually mean the percent of system processes that are using CPU. In other words, that is actually the CPU usage in percent of system processes. That's the overall information that we get using the DAG system. But how do we kill processes, and how do we toggle between processes that consume more CPU or more memory? That is coming up in the next video. Once you have deployed your access point or bunch of access point in your company space, get familiar with the term channel utilization. The more it is utilized, that is the percent of time the channel is busy transferring packets, when more energy is detected, the less throughput you will get. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. When you deploy real-time applications such as voice over IP and video streaming, the recommendation is that you won't have more than 50% airtime utilization. Now, what makes it utilized? Bunch of things. Many SSIDs that send beacons in the air takes up airtime. That's why you don't want too many SSIDs in your network. The beacon interval, which usually is 100 milliseconds, is also responsible for the utilization of your channel, and old clients that support the old standards of B and G also utilize a lot of airtime. So what do? For start, let's change our beacon interval in our access point, and trust me, you will see a dramatic change in the channel utilization. So let's head over to our command line, config wireless controller. Let's make it config wireless controller WTP profile. And now let's edit let's see what we have. We have only a radio that supports 11N, but that's okay. And now let's config radio 1. Alright, and let's set the beacon interval. As I said, usually it is 100 milliseconds. We can put an integer between 40 milliseconds and up to 3.5 seconds. Let's put the 300 milliseconds. So every 300 milliseconds, our access point will send a beacon frame, and that will lower the channel utilization significantly. We have already learned how we can list system processes and show their output on the command line. Now on this video we will look at how we can kill different processes that consumes too much memory or too much CPU power, and how we can list the highest demanding processes on our Fortigate. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. So you're using a high-level encryption in your VPN, you're using IPS to scan different patterns and anomalies, you're using antivirus, and you keep logging of just about anything. Well, all of that consumes lots and lots of CPU resources and memory. Let's take a look at the DAG system command. Let's make an interval of 20 with 10 processes. Alright, now using the M character, you just need to type the M character. We can sort out the processes that consumes the highest memory and in our case it is the DNS proxy. If we press the P character, that P is for CPU, we will see the different processes that consume the highest CPU resources, and in our case it is HTTPS daemon. Now the next step is to kill the process that causes you lots of issues. That is the last step before you reboot your Fortigate. Let's do a Control C. To kill a process, you use the diag sys kill. Now you enter what is called a signal. That is a term that comes from Linux and Unix, which is actually a polite way to ask your system to stop the process, and it can be a more aggressive way to tell your system, it depends on the number, to tell your system to kill the process. Now we can use different signal numbers. We will use 15, which is an aggressive way to tell your system kill that process, and we will list the process ID. Now the process ID, as we know, is the second column. So let's use the DNS proxy process, which is 94. Alright, now we have just killed that process. And here we can see that the DNS proxy process has actually been terminated. We saw that we can list processes, sort them out, and even terminate them whenever they demand too much resources. On our last part of knowing your processes, we will see how we can, in one CLI command, see the top most CPU demanding processes. To get more easy setup tips for your Fortigate firewall, subscribe now and don't forget to click on the bell notification and you won't miss anything. One of the features that we saw using the diag systop command is that we can list the most demanding processes, either CPU and memory, using the M and the P character when it is pressed. Now there is another command, which is the get system performance top, which lists only the most demanding CPU processes. Let's see it in action. So we use the get sys, sorry for that, get sys performance top. Now you will see the most demanding processes, the most CPU demanding processes at the second most right column. That's the CPU column. The most right column is, as we know, the memory column. Now you will see different processes such as the IPS engine or the antivirus scanner, the new CLI, or even the SSHD, the SSH daemon. Now, whenever a process is too demanding in terms of CPU, you may need to kill that process, and we saw how to do it using the diag sys kill with a signal level and the process ID. So your access points have been deployed. How can you limit the amount of clients that will connect to your access point, to a specific access point? Client limitation is crucial whenever you have high density deployments and you want your clients to move between access point whenever there is a good signal strength between them and an adjacent access point. Well, you can limit the threshold, you can limit the amount of clients. It can be 10, 20, 30 clients per access point. But you can also control the threshold, the load balancing threshold. So whenever a client has enough signal strength to another access point, it will roam to that access point. Let's see how we do it. All right, so let's use our command line to enable the access point handoff, to limit the number of clients to that access point, and to configure a threshold. So let's configure the wireless controller WTP profile. There it is. And let's use one of the default profiles, which is the 11N only. Let's configure the radio, and let's set the access point handoff to enable. All right. And now let's move back and configure the handoff station threshold and limit it to only 15 clients. So only 15 clients will connect to that access point before the load balancing mechanism will start to work. And the last thing to do is to set the handoff RSSI. And let's use a handoff RSSI of 30. Now, in the case where our clients will try to connect to our access point, the controller, our FortiGate that serves as a controller, will signal the client to connect to another access point.